the tech teacher here. Today we are going to go through a new LeetCode problem. It's called validated stack sequences. Before we start, if you like our content, like the video, subscribe to the channel and activate the notifications so that you can receive all of our updates. Let's jump right into the problem. So the problem is talking about a stack data structure given two integer arrays, pushed and pop, each with distinct values. Return true if this could have been the result of a sequence of push and pop operations on an initially empty stack, or false otherwise. So basically these are the values that will be pushed and these are the values that are popped. So we should return true or false based on if these sequences match for a stack. So what makes this problem a little bit easy are the constraints. So first, the idea of distinct values makes it simple, because for instance we will have only 4 ones here, so that when we see 4 in the popped list or popped array, this means that this 4 is the one. We don't need to search in every element in the pushed array. So the way to do or solve this problem is by basically simulating what will happen. Let's start first by going through these examples. So we have 1, 2, 3, 4, 5 in the pushed, and then we have popped 4, starts with 4. So this means that the push for 1, 2, 3, 4 happened first, then we call pop. So the one popped was 4. Then since we see 5, this means that this push operation happened first, then pop returns this 5, and then the contents of the stack are 3 and 2 and 1, which matches the contents here. So this scenario makes sense. That's why we return true. But in the second test case, we have the same pushed, but we have 4, then 3, then 5, then 1, then 2. So then we have push 1, 2, 3, 4, pop 4, and then pop again, which returned the 3. That's fair. Then we have the 5 here, so this means that push 5 happened first, right? So then pop return 5, and then pop return 1, which is not true because the peak of the stack is currently 2, not 1. That's why we are returning false. So the way to proceed with such a problem is that we first try to push elements into the stack, right? And then with every pushed element we try if the corresponding or the current value in the popped array match this one, then we will pop from the stack, and we will continue popping from the stack till the peak of the stack is different from the next element in the popped array, or the pushed or the stack is empty. Let's start by implementing this solution. So first we will define our stack of integer stack equal new stack, right? And then we will have 2 indices, one for pushed and one for pop. So let's call it push index equals 0, and then pop index equals 0 as well. Then we will loop till the pushed array is finished, right? While pushed index smaller than pushed with length, we will have our loop, and then at the end of the loop we will increase the index, right? Right, so what will we do in every step? So first we will add the current element in the pushed array, pushed index, and then we will add this element to the stack.push this element, right? Then we will pop from the stack as long as we can. What does this mean? So we will pop from the stack if the current element in the popped array matches the peak of the stack, which means that we will have some conditions here. While first stack dot is empty is false, means that there are still elements in the stack, right? And stack dot peak, first let's check the index. So and pop index is still smaller than popped dot length. And then the last condition is that the peak of the stack equals to the current element in the popped array, like this. So if the three conditions are true, like this, let's clean this up a little bit. So if the three conditions are true, then we can simply pop from the stack and then we can increase the pop index like this. That's it. And then after all of this finishes, we should check that we have consumed all elements in the stack. So stack should be empty, and that we have consumed as well all element in the popped list, meaning that the pop index is equal to popped dot length. Let's run. So we have pushed index, sorry, it's called push index, not pushed index. Let's run again. Oh, got accepted. Let's submit. Alright, so it got accepted. That's it for today's problem. If you like the problem, the solution, feel free to like the video, subscribe the channel, and click the notification button in order to receive our updates as fast as possible. And see you in the next video.